going?
All right, very good. So we're going to be looking at a BJT problem. With BJTs, we know that there are three modes of operation. There's cutoff, there's the active mode, and there's saturation. What we normally do is assume the active mode and then check our assumption. So if we assume the active mode, what we're going to do is replace the transistor symbol with its model, circuit model in the active region. And that model is a 0.7 volt drop from the base to the emitter. And then there is a dependent current source here of beta IB. Beta, I didn't write it down, I should have. The beta for this problem will be 100. So our current source is beta IB. Now what we're going to do is solve for the circuit variables. And what we're going to solve for is VB, VC, VE, IB, IC, IE. Then we're going to check to make sure that our assumption is correct. So let's start with finding out VE. That's easy because VE is attached to ground. So the voltage at E with respect to ground is simply 0. The voltage at B is 0.7 volts higher than ground. VC, well, we don't know the voltage drop from C to E, so we can't figure that out yet. I could figure out IB. IB is the current going into the base. If I do KVL from here to here, we'd have 5 minus, so we're going to drops our negative, so we're at 5 volts and we're dropping 1K IB. And that, 5 minus 1K IB minus 0.7, that's the voltage drop here, and we're at ground. So we can solve this for IB. IB is equal to 4.3 milliamps. That's quite high for a base current. IC is beta IB, so that gives me 430 milliamps. Now I can find out VC. VC is equal to 10 minus this drop, minus the 3K IC. And what we get is 10 minus the K and the milli cancel, so it's 3 times 430, that's about 1200, minus 1200. That's approximate. So this is a big negative number. Now remember, in order to be in saturation, VCE must be bigger than 0.2 volts. Clearly, VCE, which is VC minus VE, is not bigger than 0.2 volts. Therefore, the assumption of active mode is incorrect. So we have to rework the problem. All this is, well, most of it's wrong. Some of it's right. What we have to do now is assume that we are in the saturation region. Now notice that IB was positive. We did get current going into the base, so we're not cut off. We're in saturation. So now what we do is we put in our saturation model, which again is 0.7 volt drop here, and a 0.2 volt drop from collector to emitter. So let's go and figure out what's wrong. This is still okay. This is okay. This is no longer true. This is only true for the active region. Remember, we had that dependent source there. Not true. And anything that relied on that value is incorrect as well. So we'll have to rework our solution from here. I could figure out IC. We'll do KVL from here to here. We would have 10 volts minus a voltage drop of 3K IC minus 0.2 equals 0, because we're ground. Now we can solve for IC. IC is 9.8 volts divided by 3K. This is approximately 3.3 milliamps. VC is 10 minus 3K IC. Oh, actually I don't even need to do that, do I? I can actually tell by inspection VC is 0.2 volts higher than ground, so I can write VC is equal to 0.2 volts. So let's see, have I got all the parameters I need? I've got VB, VC, VB, IB, IC. The only thing I don't have is IE, this current. By KCL, IE is equal to IB plus IC. And that's going to be this current plus this current. So you're going to get about 7.6 milliamps. Hope that helps. To summarize, the way we do this is we assume a mode of operation for the transistor. I would recommend that you assume active region. You do the calculations, and you have to make sure that your assumption is correct. IB must be going into the base. If it turns out it's going this way, that would indicate you're in cutoff. The other thing that has to be true is VC must be 0.2 volts or greater than E. In this example, it wasn't, and so our assumption was incorrect. And we have to rework the problem then with the saturation mode assumption. We put in the new circuit model and we do our calculations. I hope that was helpful to you. Thank you. Colin, I brought in your tablet, and it's still going, I think, so if I just hit this.